number name combination is wrong, number expiry date combination is wrong, number card security code combination is wrong. Just those by themselves. Everything else is fine, but those by themselves are not okay. So boom, it's not a real account. Okay. We can also say, though, that it's also possible that we could have 3 different ways for 2 things to mismatch. So what if we have a mismatch here between the number and the name and the number and the expiry date? So those don't match. So whoops, that's invalid. Here's another possibility: the number and the expiry date and the number and the card security code don't match. Okay. And then we can say, well, the card security code and the number and the name of the number don't match. So now we've got 6 equivalence classes there, and then we could say, well, there's even a 7th equivalence class, where we say that none of these 3 things match. They're all out of sync. Okay. So if you're interested in testing every possible way that condition could occur, the not a real account, then you would be looking at 7 tests to cover the equivalence partitions. And we can also use boundary values in combination here. So let's say we look at the within limit condition. That's here, right? So we've got yeses and nos there. Now, we can do boundary value analysis and say, look on this line here, and they got some range of values for what the balance is, right? What's the current balance? So we could have a 0, right? Some sort of normal at typical value in the middle of the range potentially, and then we could have, it's going to be exactly at the limit after the transaction. It could be exactly over the limit by 1 cent after the transaction. Could be exactly at the limit before the transaction, of course, so any subsequent transaction would push it over, and then maximum over limit after the transaction was approved, if it were to be approved. Of course, it's not supposed to be. So what we would have is 4 within limit tests. All right, so there's a limit, limit, right? And then we've got the 3 over limit tests here. Okay. So, okay, well, we're good on the within limits, because see here, this is a within limit, and there's the 4th, right? So these 3 values that we identify, boundary value analysis, would fit just fine within those 4 tests that we need to create. So we can easily cover these guys in one of these 4 columns. Now, in terms of the over limit, well, we only have this guy and this guy, right? So we'd actually have to cover one of these columns twice to cover this one here, or the other one, whichever was the odd person out, right? So that's something to keep in mind, is that in some cases, in the equivalence partitioning or boundary value analysis acts on a single table, or excuse me, in a single column. In other cases, it can act on a condition in the row, basically, and it can identify some set of tests that then have to be covered across the columns. So certainly possible to combine them as shown here, and I think as a matter of competently applying this technique, we probably should. Pardon me, get a drink of water here. Okay, now, non-exclusive rules. The decision tables that we've been looking at so far were such that at any given point in time, only one column, only one rule would apply to a set of conditions. It is also possible to have one or more what are called non-exclusive rules, and I'll show you an example of this. Let's suppose that we were testing credit card processing, end-of-month processing of credit card. And if you have purchased money, you made a purchase, whether money or an object, in foreign currency. Many credit cards, for example, Citibank does this, which is a source of great frustration to me. If there is foreign exchange, there's an exchange fee that gets charged. Just boom, you get automatically hit with it. Doesn't matter what else is true of your account, you're going to get hit with that exchange fee right now. If you carried a balance from the previous invoice, you will get charged interest. Now, doesn't matter what else might be true. And if your payment was late last time, will you get charged a late fee? Yes, you will get charged a late fee. Right? Now, see, none of those things might be true, so none of these rules might apply. One of those things might be true. Just one of the columns applies. Two of those things might be true, and that could be one with two, one with three, or two with three. So there are three different combinations there that could apply, right? And then all three of them could be true. They're independent, and they can combine with each other. So watch for that. Usually you'll notice, you'll see in these kind of independent non-exclusive rule columns where there'll be a single condition or maybe two conditions or something that are specified as having to be yes or no, and then everything else is a don't care. And similarly, in the actions, there's a single action which is to be taken or not taken based on that particular condition or combination of conditions, and everything else is a dash, which means these actions are not determined by this set of conditions. Now, what do you do with this? I mean, obviously, there's a lot of combinational problems that could occur here, combinational tests that could occur. Well, we want to avoid testing a lot of combinations. That's the combinatorial explosion is the bane of the tester's life. We're going to talk about that in the context of pairwise testing and domain analysis, probably in some future webinar, advanced testing webinar. But for the moment, we're not focused on combinations. So what you want to typically do is first you test every rule by itself. And you do it completely independently, so that no conditions that are not related to that rule are met. In other words, there can't be any situation where some other condition that is not specified in the rule, in other words, it was one of these dash guys, inadvertently is responsible for triggering the action. You test the rule clean, and then you consider testing of combinations, but again, avoid combinatorial explosions. Maybe you test some subset of the combinations, and then one combination where everything that could combine together does combine together, and use risk to pick which combinations to test. Okay, so that is decision tables. And so we've now looked at decision tables and cause-effect graphs and their use for testing. As I said, these are useful for testing of internal business logic and applications, and they can become quite sophisticated and complex. What you've seen are small examples of decision tables. I've seen them 40, 50 columns wide before, so they can definitely grow. They're still much more complex than, or excuse me, much simpler, much more straightforward than a prose explanation, a text explanation of the similar logic would be. And that's true for a lot of these techniques that we're going to look at, state diagrams and decision tables and use cases and domain analysis and those sort of things, that the text description of this stuff is a lot more difficult to read and often a lot longer than the tables themselves. So decision tables are a great way to test detailed business rules in isolation. Once we get into combinational situations, that starts to become problematic, and as I said, we'll talk about that a little bit later. It also, again, remember that we're talking about transactional stuff here, where things that have happened before don't affect what's happening now. We're going to look at other techniques that are not limited in their usefulness to transactional situations in some subsequent